David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you can turn on the captions and follow along with my words on the bottom of your screen. Okay, let's deepen our discussion of functions. So remember, the last lesson was relations and functions, and now we're going to just stay with functions. So what we're going to talk about in this lesson is domain and range, intervals for functions, and then also graphing functions, and we'll talk about graphing them on your GDC, on your fancy schmancy graphing calculator. Okay, so let's get started. First off, some definitions. Domain. This is just something you have to remember, okay? The domain is the set of all the things you can put into the function, okay? So these are all the input values. These are what you put in for x. So in a very real sense, these are the x values. So that's the domain. And the way I think of that is the domain is my domain. I control that. And it's very true. You control what you put in the function. So that's your control, your domain, x values. Now the range is the set of all outputs. So that's what happens when you put an x value in there and the function does its math on it and it spits out a number. That's the output. That's the y value, and that's called the range. And the way I think about that is the range is the prairie where the cows graze. It's out on the range. It's out there. It's not my domain. It's out there. So that's the range. Now you may have other ways to remember it, which is just fine, but I notice that students get these mixed up or they forget what they mean entirely. So this is a good thing to make sure you know. There are questions on tests and quizzes that require that you understand the words so that you can answer those questions correctly. Now let's just take a look at how this might look for a couple different functions. First off, y equals x squared. This is the friendly parabola that you've graphed a bunch of times. We've played with this in a lot of other classes. So what's the domain? Now, a way to answer that question is, what can I put in for x? And the truth is, I can put anything in there. I can put negative numbers, I can put pi in there, I can put root of 2 in there. There's no limitation to what I can put in there. So the domain is all real numbers. I'm just going to use the symbol for real numbers. Real numbers are any number that you could put on a number line. And that does include irrational numbers. So there's no limits on the domain on this one. Now how about the range? This is a little tougher. Think about that. What values can we get out of this function? Because there's some values we will never get out. Okay, so I'm going to use set builder notation to answer this question. But first off, the user-friendly answer is I can't get negatives. If I put negative 2 in for x, I could do that. That's fine. I'll square it, and that gives me positive 4. So no matter what negative number you put in for x, you're always going to get a positive number out, or 0. So the way we write that is curly brackets like this. And what that means, I'll read it off to you, the set of all x such that x is greater than 0 and x is an element of the real numbers. Okay, so this is the set that is the range. You could use this, you could say shorthand is just, real numbers greater than or equal to 0, and that would be fine. If you just wrote that, I would know what you mean. So this is all real numbers greater than or equal to 0. That's the range. Okay, let's put some of these ideas to work. Here's an example problem of a type you might see on a homework. Here's our function. Standard linear function, y equals 3x plus 2. Okay? So the first instruction here is find the range if the domain is this. Okay, so for this particular activity, the values for the domain, the x values that we're considering are only these four, negative 1, 0, 1, and 2. Okay, so we're not considering any other input. Okay? So this is find the range. So if the domain is that, the function is that, think for a minute, how would you find the range? Okay, if you thought, oh, all I got to do is take my domain and plug it in, because it's input into my function, do the math, and get output, the range. And you would be right. So let's do the first one, then I'm going to let you do the rest. We're going to take -1, plug it in. Y equals 3 times -1 plus 2. 3 times -1 is 3, plus 2 is -1. So the range, I'm going to write that here, can be expressed as a set that's starting with -1. But it's going to have 3 more values. So pause the video now and calculate those 3 values. Okay, here's my range. 2, 5, and 8 get added to the list. And if you missed that and you want to check, I've got my work all along there. So pause the video and check that and make sure you could do this calculation. Okay, so now let's go on to another type of question you might see. True or false? The point, -3, 7, lies on the graph of this function. So at first you might not even understand what this question is asking, so let's tease that apart. This function can be graphed. This is a linear function with a slope of 3 and a y-intercept of 2. So if you remember from your basic algebra and graphing lines, you could graph this one all day. So what this question is saying, is this point on the graph of this function? And there's a super easy way to check. If -3, 7 works, that means that if you put -3 in for x, you should get 7 out of the function. So let's check that out. And I'm going to do it this way. I'm going to do 7 equals, with a question mark, because I don't know, 3 times -3 plus 2. Right? Because that's my function, 3x, x is -3. And I think you're seeing where this is going. It doesn't look good for our point here. 3 times -3 is -9, plus 2 is -7. So in this case, this point does not lie on the graph of that function. Okay, so let's do this last question. Find the image if x equals 6. And you might be going, what? And truly speaking, that's kind of a weird way to ask the question. So pause the video and just think if you can figure out what they really want. And if you think you got that, do the math. Okay, if you honed in on the fact that we're saying x equals 6, then you might have gotten to the point that the image is the y value. So the y value, the image of 6, is going to be plugging 6 into our function and seeing what y we get. So let's do that. Y equals 3 times 6 plus 2. 3 sixes is 18, plus 2 is 20. So 20 is the image of 6 under the function y equals 3x plus 2. Okay, let's take a look at another example here. Here's my function, pretty simple linear function, y equals x plus 1. But now we're saying something. We're saying where -2 is less than or equal to x is less than or equal to 1. So since this is x, this is a statement about the range. This is saying we're only going to put x values that are greater than or equal to -2 and less than or equal to 1. Okay? So we're limiting what we can do with this function because this function goes forever. You can put bigger and bigger numbers or smaller and smaller numbers, so there's no limit to this function. So what we've done here is we've limited with this statement. So first question, write down the domain. Okay? Now, I just told you that this statement talks about the domain. Okay? So let's write that in set builder. Set of all x such that x is between -2 and 1. And if you're being thorough, you can write x is an element of the real numbers. Okay? Now that's in set builder. Now we have this other notation, it's interval notation, which just goes like this. -2 to 1. And this notation, now square brackets, okay, so it's not the curly brackets, the square brackets. This means it's between -2 and 1 inclusive, which means it includes these, okay? So this is a nice shorthand way to write that. Okay, let's go on. use the GDC, Graphic Display Calculator, the fancy schmancy one, to sketch, clearly indicating the endpoints. So this is a request for you to get out your calculator and put the graph in. And this is where that calculator really pays for itself. Instead of having to laboriously create hand graphs, plotting points, then draw your lines, you can just enter the equation into your calculator and it will create the graph for you. So when the graphs get more complicated, when the functions get more complicated, this calculator becomes even more useful. So I'm going to put a link in the video in the comments below that links you to a video that shows you how to do that for the TI Inspire. So I'm just going to assume that that happened. Let's say we paused, we did that, we put that in there. It says sketch. So sketch is a key word for the IB. It means a roughly accurate graph. It doesn't mean a perfect graph. It means a roughly accurate one. Okay, here's my graph. Just looked at the calculator and I put my axes in there. I put a couple tick marks here and there on the scale so that you knew what that was. And then key, I've indicated my endpoints clearly. So I know that this is the point 1, 2, and this is the point negative 2, 1. Okay? So this is not created by plotting points and writing points down. This was created by looking at my calculator, putting in my graph, and checking out what my function was like. Okay? Now on the calculator, the graph goes forever. So there's a couple tricks in that video that I linked to below that shows you how to limit it so that it just goes to those 2 points. And then there's a bunch of other tricks on that calculator that let you tell you exactly what certain points are, and we'll get into that a little later. All right, so now let's go on to the last part of this question. State the range of the function. Now just like sketch, this is a key word in the IB. You want to remember that that means create a roughly accurate graph, which we did. State is your clue that whatever they're asking for is something you can simply look somewhere and see it and write it down. If it says state and you find yourself calculating, you're on the wrong path. If it says state, or another word like that is list, list also is a clue that you do not need to calculate. You should just be able to grab what you want from somewhere else in the problem that you're working. Okay? So in this case, actually before I do that, see if you can state the range of the function. That's the y values. It's right there. Okay, let's see how you did. The y values are the up and down, right? So the range is from y equals -1 to y equals 2. Okay? So we could do it in set notation, the set of all x such that x is bigger than or equal to -1 and less than or equal to 2. So that's set builder notation for the y values. There's -1 and 2. And then of course we can use this interval notation, which is super handy. Like that. And I realized I made a mistake there. What should go there? Not x, but y, because that's what we're mapping. Set of all y. Sorry about that. Fix your notes so that it's correct. Okay, one last example problem. Check this out. A relation is shown to the left. So here's a graph of a relation. Some relating of ordered pairs of x's and y's. Okay? Our first question, is this a function? Now this question could be a little tough to answer because remember we had to decide whether it was a one-to-one, one-to-many, many-to-one, and there's 2 of those that qualify as a function, 1 does not. So think about that and then see if you can answer this question. Is this a function? Okay, if you thought yes, you're correct. It is yes. And of course, a question might ask you to explain why. And the reason why is that we have a many-to-one relationship. Because here, when x is 1 or x is -1, y is still 0. So this is the point -1, 0, and this is the point 1, 0. And that's okay, because that's a many-to-one. These 2 different values, the many, resolve to the same one. That's okay. It's the one-to-many that doesn't work, and we don't have that here. So in this case, it is a function. We have a many to one. Okay, so that's the answer to that one. Now, list the domain. So you should be able to grab that right off of here. So pause the video and see if you can write down the domain. Okay, remember, domain is the x value. The domain is what I control. I get to choose. I get to choose what x is. The function tells me what y is. So my domain is simply going to be the range of the x values. And the x values are along this axis. So it is -2 and 1. That's the range. Okay? I'm sorry, the domain. Now, think about the range. Pause the video and see if you can write down the range. Okay, the range is the output of the function, or the y values, so that's just simply the range of the y's. So the y goes from -1 to 3. So we just put that like that. There you go. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.